I'm going to be trying out a new format in this video. So what I'm doing is basically analyzing, or I sometimes call it auditing, some code that I've just written. So I did this 7-day roguelike jam. I originally wasn't planning on doing the 7-day roguelike jam. I was planning on doing a month-long jam just by myself, and it turned out that what I was making was a roguelike and happened to line up exactly with the 7-day roguelike for the year of 2024. So I decided I would sort of adjust my plan a little bit and rush along some ideas to make it fit into that 7-day time window and have something to submit. And in some ways that was helpful. It, gave me a chance to show it to more people. And it gave me a framework for analyzing what to add to the game more quickly, sort of, to make it fit in with the 7-day roguelike restrictions a little bit more. I had to rush to certain features. And at the same time, needing to do that influenced the direction of the experiment I was trying to run. And so now I want to take a look again at what I did and fully make sure I see what's happening and use the sort of the understanding that I build by re-looking at it as a chance to analyze what aspects of what I've built aren't in line with where I actually want to be going, and use this as a chance to unwind some of that stuff now and course correct. So the format here is going to be fairly informal. I'm not scripting this. What I'm actually doing is sort of like a devlog, except it's not something I'm putting out to update you on my project or something. It's actually sort of a part of my own thinking process. I want to do this either way, but it's going to be much more helpful to me to articulate these ideas out loud and draw some pictures. And so along the way, I'm going to try to show you what I'm looking at, whether it's some code or some diagrams I'm drawing. But it's really, first and foremost, a process that I want to go through to understand the project's current state and to come up with some plans for what to do next. And I thought, since I'm going to be doing this anyways, I'd love to share it, and I'd also love to get feedback on some of this thinking. But you're really just seeing a raw sort of thinking out loud process throughout this entire one. And, I don't know how well that will be received. Maybe no one will want to see this kind of thing again. Maybe it might inspire people to try a similar kind of analysis process. I have no idea. But I know it kind of changes the process for me a little bit. Having someone to talk to changes a little bit the way my thought process works in a way that I think might be helpful to me. So at least for this one, I'm going to make all this assuming that most of it will get to the audience. And I might edit out a few things to respect your time, if I find myself completely rambling for no good reason. But for the most part, you're getting just me thinking out loud to myself in order to figure out next steps. And if that's valuable to you, great. But if not, it was valuable to me to share it anyways. All right, first thing I'd like to look at is that I have my engine here divided into two main layers. There's what I call the app layer, and then there's the QU layer, which QU is just the abbreviation that I used for all of the game-specific stuff. The name I started with was the quest, so QU is the first two letters of the word quest, and that's just the namespace that I'm using for all of the game state stuff. But I want to zoom in on the app layer and talk about what its purpose is, how it relates to the game layer, and then all of the features that are currently coming out of that layer, what's provided there. So the app layer exists to contain all of the things that are not particularly game specific, that are sort of global data that I want to provide. So they're not a part of like reusable function libraries or something. They're not simple data in, data out. They're a part of the main loop or a cache layer for a particular type of data, random number generators that are, seedless, as in the API doesn't force you to manage the seed. The seed is sort of global and hidden from you in the APIs, stuff like that. So I'm going to run through real quick what all those specific things are. But the main idea is that these are things you wouldn't use in necessarily other apps, but you would maybe not consider them being specifically related to this game. So it wouldn't be crazy to make a different game on top of the same app layer. Another way to think about it is these are so generic that they're almost reusable, but they are tied in with the main loop of the app. And so they're also not reusable in any context. They really only make sense in at least places where you have a main loop to begin with. Okay, so the first thing it can do is it can return, I've got a function called app game state. All that one does is return to you the root structure of the whole game data. And so that's in this layer just because that means from any part of the code, I can call this and it returns back that game state. So I can get access game state from anywhere. Now, I don't think I'm going to end up accessing game state from anywhere in the app layer. It's more so any of the game code can access the root layer of the game, or the root node of the game state. Then I have some stuff dealing with the frame state. So there's, the delta time, the size of the window, the inputs to the current frame, including, events and the mouse position. I have a construct called the frame arena, which is a little more interesting. The frame arena changes every frame, but it's swapping back and forth between two different arenas. So on each frame, there's a current arena that starts at position 0. It starts empty and fills up with stuff for that frame. But the most important thing about the frame arena is that the things I put on the frame arena are still available in the next frame. So I don't clear the arena until I start using it at the beginning of the frame, and then I swap it. So it sort of sits in a previous arena slot for one frame. And that means if I allocate something in one frame and I want to be able to hold a pointer to that for a frame, that will still be valid, right? So every time I ask for the frame arena, I'm asking for the current frame arena that I can write stuff into. There's no accessor for the previous arena because you don't modify the previous arena. It just sits there holding the data for you from last frame. And then I have a function called size scale. This is a sort of scuffed, hacked way of taking in a size for something I want to display on the screen and rescaling that to the actual dimensions on the target, right? So if you're running my game on a smaller monitor than the one I developed for, I want all the font sizes to shrink so that the layouts still fit on your screen. So I developed for a 1920 by 1080 monitor, but if you're actually on something smaller, right, like a 1300-ish kind of size, whatever that resolution is, I'm blanking on at the moment, it can just look at the ratio between what size you put in and scale that down to, if their monitor has these dimensions, then let's scale the font sizes down a certain amount. It's not the most robust solution. There are still things like layout related and high DPI related that aren't actually being handled. So there's a whole bunch of engine stuff to develop in that direction if I want to make it more powerful. But that's what that's doing. I have a font cache. All the font cache does is store a fixed number of slots. I think I hard-coded in 10. And it takes in an ID. And so the ID is there. Each font asset is preloaded at the beginning of execution and given an ID. And then while you're running the game, it uses fonts by specifying an ID and a size. And the size is scaled by that scaling thing from earlier up on the list, and it then renders out the font if it's not already in the cache. But if it finds that particular ID and size pair somewhere in the cache, it then uses the existing rasterized version of the font. So you only get new rasterization work happening when someone requests a font that hasn't shown up yet. It's not the best thing ever. There are some issues with doing fonts this way. For one thing, if I switch between fonts a lot, including switching between font sizes, right? Even if I use the same font on 2 lines, having them just at different sizes means they are separate textures in the back end. And so if I wanted to push this further, I would not have separate font handles that correspond to separate low-level textures. Rather, I would have a single low-level texture that contains all of the glyphs that are necessary for a particular frame, and then loading in new glyphs instead of loading in whole fonts into font slots. So there's like a way to do this with a finer granularity that uses a single texture that I'm not currently supporting. So that's a path where there are some upgrades to do on this layer. And then I have some RNG stuff. And there's a lot of stuff I could imagine doing here. I don't have particularly strong opinions on what a good RNG layer should look like yet. I want it to do more high-level stuff than just roll me a U32. And by roll, I mean like generate a random U32 or generate a random float. Like I want it to be able to do things like, hey, grab me, do choose operations. So like if I have a set of 10 things and I want to randomly pick 5, but I don't want any duplicates, that's a slightly more subtle thing than just pick a random number. And so having like helpers for, here's a construct that I want to build. I want to construct this thing randomly. Here's the kind, something I want a random instance of. Would be interesting to me, and I think there's a lot more work to do to choose good primitives and avoid redundancy and stuff like that I haven't done in this layer. So, that's fine. It's also just not that big a deal. If this is a poor one, switching this out doesn't really impact a lot of the other stuff I'm interested in. This is a isolatable research question, as it just affects what the RNG code paths look like. It doesn't affect things like the rest of the game engine's data management or stuff we'll get into in other layers here. So while it's poor, I don't think that getting into ways that I could improve that matters now. But again, another layer where upgrades are possible. The main structure of the game logic is defined in these handful of functions. So the constant init just sets up game constants, things that won't change after they're initialized, or things that don't get freed and reallocated, or things like that, things which only need to happen once at the very beginning of the program. Run init, this is a game that contains runs like a roguelike. So each run, I need some path where things like world generation or initializing the state, clearing, making sure the entities are a certain way or whatever, all of that can happen to set up the beginning of a run there. And then there's tick and draw, each of which happen every frame. So every frame there's a tick, and every frame there's a draw. Inside of tick, you can do whatever logic you want. Inside of draw, it's supposed to be that you don't do any update to the game state. You only do rendering logic. Now, you can't do any rendering logic in tick because rendering isn't targeted, like the window isn't targeted for rendering output, but you can do OpenGL operations like setting up textures and stuff. So you could do off-screen rendering too if you wanted. You could target a frame buffer or something and then use it later. And similarly, in draw, you could break the rule and change state. So they're almost unnecessary. You could imagine doing just a single function here, but I like the feeling of having it split a little better. And you'll see when we look at the definitions of each of these that I do actually follow the rule exactly. Now looking at constant init, very simple, allocates the world arena and initializes a color palette. Nothing I think worth thinking about here yet. Looking at QU run init, things start to get a little bit more interesting. There's clearing the world arena. So between runs, we just zero out the arena. We keep the memory, but we release all of it to reuse it. And then we zero out the entirety of a block inside the game state called logic. So with the exception of a couple of things, most stuff is inside this logic block. And all of that is stuff we want to have zeroed out at the beginning of each run. And then I initialize a couple things. I initialize current fragment to QUS intro, and I initialize a couple of game counters. Now, I don't think I'm going to learn much from just looking at the init code, but this does highlight to me that it's going to be important along the way to place all of the code we're looking at sort of next to relevant types. So let's start doing that as well. So you can see the game state struct is a big honker, doesn't fit on a single page. So, I have to put it side by side a little bit. The only things we've seen so far are the world arena, the color palette, the current fragment, and then the next time counters for recharge and fatigue. Now, taking a look at what's coming up next with QU tick and QU draw, I'm not going to be able to just explain all of tick in one go because tick is quite a big function. It's got a lot of the logic of the game in it. Not all of it, maybe like 20% or so. And I want to talk about why it's layered in that way, but I do want to talk a little bit about the main top level structure of tick and the top level structure of draw. I can actually show you draw. It's very simple. And so you can see all that's happening when we go to draw the game is we're doing a loop over this array of layouts. And we can see in the game state struct, there are only 2 layouts, although it does come with a count. So that can be a 1 or a 2. We can have 1 or 2 of these fancy string layout things. And we just tell it to draw each of them and we're done. So the way drawing actually gets done is that very little logic happens at the game layer. It's all defined by that fancy string. And the fancy string is just sitting there living in the game state. Now, the top level structure of the tick function is going to be that it's going to be the thing that generates that fancy string layout, or, it's going to build the fancy string, lay it out, give it a position and all of that. And then it's also going to update the game state. So it's going to process anything it needs to do to modify the state of the game over time. So it's sort of split into 2 purposes. One, generating the structure of the fancy strings that go to the draw function, and then also updating the game logic. All right, now I'm going to try to read through tick and make sense of its total structure. How this ends up looking, I have no idea because I've got such a long function here that I've taken some screenshots, and whether or not I can piece together the visuals in a way that helps you follow or not, I'm not sure right now, but I need to go through this for myself anyway, so hopefully this is bearable. All right, so at the very beginning, I'm just grabbing a bunch of constants and setting up a scratch arena. They're not constants, but like globals, I should say. I'm grabbing a bunch of globals. Some of them are fixed for the frame. Some of them are the technically constant pointer to the game state struct, although technically, it's not usefully constant because the pointer is constant, but the game state isn't, and so on. Then we actually get started by this begin alive section. So the alive system is a part of the fancy string system, and the alive part is where we handle interactions between frames. So like if I hover a piece of alive text, the highlight on it glows brighter. And if it's alive, I can also attach reactions, or what I call payloads, that get processed if I click it. So right now it's sort of like a button. It's a button. And there might be other ways that I want to make things alive, like making them click and draggable, or make them not necessarily immediately change the state of the game, but unfold bonus text or have sort of like tooltip types of things where you hover them and more becomes visible, stuff like that. So alive is basically my way of attaching things that aren't just strings and layout, but that are interactive features. And so the alive system is something that I instantiate at the beginning of each tick, and the only parameter it's taking is the previous list of alive. So the way this architecture works with the alive system is that we have a list of alives from the previous frame. Every time we generate a fancy string, along the way, we're also generating a list of these alive pieces, and they get remembered into a variable called prev alive list. And that way, in between frames, on the next frame, if I have an alive with the same ID as I had last frame, I can understand continuity between them and use the state from the previous frame and carry it over into this frame. Now, that might sound strange. Like, why do I need to keep the list from last frame? Like, why don't I just have the state in why is the state something I need to explicitly carry over? And it's a part of the design here. I don't have like an entity that is the alive entity that I can just keep referring to with the same ID between frames and let the memory stay the same. Instead, what happens is every frame I construct a list of alives from scratch, and I have to copy state over from the previous frame to the new one if I want the data to remain the same. This is a choice that I made. I'm not going to try to defend it super much, but I think it's interesting. I think it for things like this where I have a small handful of these every frame, it has some advantages. It makes it very easy to do whole system wipes of the state. It makes the memory management very easy because I don't have to worry about accidentally, generation IDs and things like that. I don't have to worry about accidentally reusing an entity slot that has the wrong state or anything like that. Instead, I just have fresh new state constructed every frame in response to the construction of the fancy string. We'll see more of that later. So moving on, the system is set up. All the system has right now is a pointer to the old list, and internally it contains like an empty list for the current frame. And the next big thing we see is the block here that actually renders out the fancy strings that we're going to see. So there's this thing called current fragment. We saw that get initialized, and that has to be non-zero because that's a function pointer. So these things called fragments are function pointers, and I think of them as instructions on how to construct a string, right? So anything that's a story fragment, I can take a story fragment and point at it with this current fragment pointer, and that means that the game will be displaying that fragment to the user. And we'll hopefully get to dig into like if that's a good design or not. I think it might be a problem, but it won't become immediately obvious while looking at this part of the project. We see that I have to, I do use the current fragment, and I have a copy of the previous frame's fragment stored in the game logic, and I use that to forget the stale alives. So remember, the alive system keeps a list of the previous alives. This is basically the zero out option. If I have changed fragments, then it assumes that I need to forget the previous alives because the IDs might be different now. There might not be constant. So the thing that had ID 3 in the previous fragment might not be the same thing that has ID 3 in the current fragment. There's no reason that the fact that I was hovering on the previous frame, the thing with ID 3, should have any bearing on whatever the thing is that has ID 3 now if the fragment has changed. This actually doesn't work. It does work if the fragment changes, but this misses if I ever have a change of state from one game state to another where the fragment didn't change. The assumption here was that changes in fragment are enough to detect changes in state that could impact layout, and that's not true. The layout of fragments can be impacted by changes in state that aren't just the fragment pointer themselves. So we're already seeing a problem in the logic here, but this is a very subtle one. You won't notice this playing the game. It's very hard to catch an issue with this. Because even though in theory there's no guarantee that a change in state always corresponds with a change in fragment, all the places where the fragment doesn't change, usually the layout remains identical, right? In order to catch this, you would need to see the layout change without the fragment changing, and that I don't know of a way to make that happen very easily. It's possible though. Then we can see underneath that part that I construct a fancy string and I store it into the main string pointer. So a fancy string gets constructed initially. They form a tree. So let me pull that struct up for you. Okay, so with the struct here, you can see it has a next pointer and a first child, last child, child count. That is the pattern for a tree with, it's not a binary tree. It's like an unbounded number of children. It's an arbitrary number of children per node type of tree. And the reason that's relevant is when I construct the main string, you can see I give it the frame arena. So I'm putting the fancy string onto the frame arena. And I don't know if that's important. The fancy strings might not actually need to get carried over, but they're on the frame arena right now. So that'd be an interesting question to investigate. Is there a good reason for me to be putting fancy strings onto the frame arena, or is the logic sound if I just say you put the fancy string into like a temporary that gets cleared at the end of like the frame arena, remember, is available to the next frame. I don't think that there's any need for that here. The alive system needs to remember to things to the next frame, but the layout of the string doesn't. Anyway, the 0 on the fancy string call there is just setting this up as a root. Now, there's a lot more I could go into about the fancy string stuff, and I might avoid that. Let me give you just an overall review of what the fancy string stuff is supposed to do, and maybe we'll need a section probably on looking into it a little bit. But the main idea is that it lets you do sort of richly formatted text. So I can put down strings, I can insert paragraphs where needed, it can do wrapping automatically when it does layout. It can do different fonts mixed together into the same layout. It can do different font sizes mixed together into the same layout. It can do different colors mixed into the same layout. It can do marking sections of the string as not being allowed to wrap. So I can take several words that have spaces in between them and say, hey, I want all of these words to stay together. So they either need to stay on, like if one of them needs to wrap, the whole group of them need to wrap together. So it's got features like that, and spacing between paragraphs and things like that. It's not as rich as it could be. And so that might be why we want to spend a little bit of time talking about what's possible there. This also attaches to the fancy alive stuff through the alive ID that you can see on the QU fancy string struct. And there's a lot of stuff we could talk about in terms of what alive features I want on the fancy strings. So that's a whole big direction to investigate, is just like how much better can the system get simply by enriching the text further. So that's another path for improvement that is clear. But using just for now the understanding that this is a structure which essentially describes some text, and it takes it from just sort of raw text with instructions to a laid out version of that text with relative positions, and automatically does things like wrapping, and it can like left align or justify or center or right align, and add colors and sizes and interactivity into the text. That is what you need to know. It's just these fancy blobs of text, these fancy strings. Okay, so we construct an empty fancy string, and then we pass it. Looking now again at this tick function, what it does is it passes that to the current fragment function. So we asserted that fragment pointer can't be 0. And we pass into the story fragment the current alive system for the frame and the main string root. And when we pass in that root, we're basically saying when you generate more text, put it inside of this root. So we created an empty root string and passed it down as a sort of destination pointer. And similarly, the alive system is sort of the destination for all of the alive features. You could also think of this as saying we're constructing these by creating the empty copies and then having the results gathered into them by these story fragments. We remember the previous fragment for the next frame, and then we have a bit of game logic here that becomes relevant that says, hey, if we're already in the state called in dungeon, so there's some intro stuff, and this is directly related to the game design now. This is not a part of a reusable engine. This is for this particular game. There's this side string, and it's a separate fancy string, and it uses the same alive system. Now that, there are some architectural issues with the fancy system, the fancy string system, that are close to being an issue here, but don't quite become an issue. The alive system requires that between frames, the fancy strings that are alive always come out in the exact same order, and that the layout isn't changing in significant ways. And that turns out to be true in these cases. Even though we have two different fancy strings being constructed on the same alive system, it works. If you wanted it to get into a situation where you had multiple partial fancy strings that were like hidden, like sort of like tabs, like, oh, if you click on this one, it reveals this portion of the fancy string, and then you click on a different one and it reveals a different portion. So they're not triggering game state updates. They're not like moves in the game, but they are navigation through the fancy string in a way. That could lead to some problems if it changes the order of strings as it happens, right? Nothing like that has been an issue yet, but I need to spend a little bit more time thinking more carefully about if just going with basic counting works. If I want to be able to construct multiple strings on the same frame using this engine, and then put them onto the screen independently of each other, does just throwing them into the same alive system continue to hold up, or do I need to upgrade the engine to make that more reliable? It's also a question of like what uses does this have? So right now it's built into the game. Like it's not a part of the engine logic, it's a part of the game logic that when you're in this particular game state, this new string comes alive. And so you can think of this whole block we're looking at here as kind of mixing logic from engine style thinking, like the current fragment, prev fragment stuff is trying to keep track of when the state has changed significantly enough that it needs to forget the previous interaction state, which is not something you necessarily want to have to manually manage in game logic, but it's mixing that right in here with in-game logic stuff like deciding whether or not to show the side string. So I think there's some another pointer to this being an underdeveloped model just in that block. All right, so far I've made it through a very small amount of the tick function, but the next few pieces I think we can fly through a little faster. So next we're looking at the part where it does some layout. These are, again, actually game logic specific because where it wants to put the strings and whether or not they exist are tied in with the game logic itself. If your game only had a main layout, not a side layout, then this code wouldn't make any sense. If you wanted multiple side layouts for different side panels, this wouldn't make any sense. So this is just sort of using the fancy string system. The main idea here is once you've constructed the basic string data structure, you pass it to the layout function and it sort of reconstructs the same string, but it assigns positions to the pieces of the string so that it achieves certain things like wrapping at a certain width if that's what you requested, justifying the text, or left aligning it depending on what you requested. And then you can query the layout that you got like for its width and height and stuff, so you can position the whole block of text in whatever way you want. After that, we see that's exactly what we do. We decide the positions for each of the blocks of text, again, very game specific in a way. And finally, we take all of that and we put it into some arrays. So instead of having these separate named pieces, finally they each like layout that we've created and each position we've created goes into an array, which will eventually, ultimately, if we go to the bottom, I assume, I think we'll see that those just go straight to the game state. And yeah, this is one of the very last things that happens in the function, in the tick function. Those layouts and the layout positions we generated earlier get saved into the game state so that they can be then rendered by the game draw function. What that makes me think is that a more fully featured version of this engine would have a feature like, hey, we recognize that probably what's going to happen is during the tick function, you're going to generate some number of fancy strings. You're going to generate layouts for each of them so that you can inspect their widths and heights, and then you're going to decide how you want to position them. And so all you have to do during the tick is declare some unbounded number of those, which are those being layouts of fancy strings and positions for those layouts. And however many you declare, we're prepared to gather them up. And so your game logic then becomes all of the things we've looked at so far, except for the current fragment piece. We would need a separate solution for that. But all the other things become, hey, you can just create some of these fancy strings and tell us where you want to put them once you're done laying them out. And the game engine takes it from there with the draw function and the interaction systems and stuff. Okay, so to sort of clean up and simplify what this appears to be implying as an architectural shape is that there's this sort of game display logic that happens that takes the game state, which is defined by the game, the game makes it up. It is not set by the engine. And the game state then goes through this display function, which is also defined by the specific game. It's not a part of the engine. And it generates this list of fancy strings that are laid out with positions and also an alive list. And those things are defined by the engine in terms of what the data structure is and the helpers for constructing them. But the data itself is being generated by this function defined by the game, right? And what's interesting about that is that sort of like I'm rendering first. Actually, it looks like the logic here is, yes, the graphical rendering happens later in the frame and separated from the tick, but the logical rendering, the sort of semantic rendering, happens before any state change and gets saved. So first thing the game engine is doing is deciding, what are we going to show the player this frame? And now if we keep looking forward, we're going to start to see a little bit more stuff that's more game engine-y and less game logic-y, and then it's going to flip back and forth a couple more times. So let's keep going through tick. So next up, there's mouse interaction. And mouse interaction is a big section because right in the middle of it, there's a giant switch that contains about 20% of the game logic, maybe 15%, something like that. But a significant chunk of game logic happens in the middle of it. But at the top here, we can see what it's really trying to do. And this is the part that is sort of engine defining. It's looking at all of the alives from this frame that were generated during the game logic part above us. And it looks at each of the alives, and I realize I haven't shown you what the alive looks like yet, so let me show you that. Okay, so you can see that an alive is sort of a node. There's a chain of these, and each alive has a payload chain attached to it. So the payload is less interesting. It's just a sort of sum type that we can make a chain of them very easily. I guess I'll show you that. Okay, so in more detail now, a payload has a next pointer. It can be used to create a linked list. These get attached to the alive structs, and then, for each type of payload or each kind of payload, I have this enum setting all the kinds, and then there's a giant union inside the payload with various different fields for different types of things that might get attached to a payload. Now, it occurs to me that there is something significant about looking at this, which is that right now, in the way this is built, first of all, the payloads are a mess. There's like lots of different ideas about what goes in there. Some of them, there's this idea of a raw state change where you can just pass in some pointer to to whatever and say, hey, I just want you to write some data into that raw pointer. And then it became more sophisticated and became like, oh, maybe you can set the game purpose, which is a specific field inside the game logic, and you can set the story fragment, which is a specific thing inside the game engine, right? And then some more game logic stuff, the game entities. There's these raw game command functions you can call. I didn't really settle on a happy story about what level of abstraction a payload sits at, and I think that's a good open question. But I don't have the ability to answer that by staring at the payload, so let's keep making forward progress. Maybe we can come up with a better answer about what payloads should be moving forward. So if we go back to looking at the alive system now, you can see each fancy alive carries a chain of those payloads, and it also carries the ID, which it uses for continuity over frames, and some state like a T for animation, and then some other stuff which is animation specific. Now, you might think, oh, if it's animation specific, that's game specific stuff, but I would think of it as engine specific because it's a little bit too difficult to say, hey, we're going to abstract and let every game define their own animations here. And it's really just a matter of like, from the perspective of the game, you just want to say like, oh, thing is alive logically. And if you want some options about how it gets displayed, you can provide those, but it'd be like saying that you want a game engine, but you want to completely customize all of the handling of models and model transforms and model animation and shading and rendering. It's like, what part of the game engine are you using? In this case, how strings get laid out, how they get animated, how they have interactive features attached. Those are sort of the game engine things that I want to say, like, you just kind of have to live with the aesthetic of the engine. Of course, it's my engine, so as I'm making games with it, I'll add the aesthetics I want anyways. But I want to think of this as below the layer of the engine game boundary. Right? It's inside that engine section, so that things like how it animates and how over time and how it interacts with a mouse are game engine specific things. Okay, having looked at that and talked about that, we can look a little more carefully at the loop here and see what it actually does. What it does is it scans over all the alives. For each alive, it then scans over all of the layout. So there's some stuff here we could do just optimization wise on the fancy system. So the fancy system could in one way it could be upgraded by saying, oh, we should give it better layout, better visual features, better control over those kinds of things. Another thing we can do is say, oh, we want more types of interaction, not just clicking, but other types of cool interactive pieces. Another thing we can do is upgrade the performance here and say, hey, instead of for each alive, scanning the entirety of every layout string and looking for substrings that have matching IDs, maybe we could start saying like, okay, let's like optimize this a little bit. Let's build a data structure where given an alive ID, we can more rapidly find all of the relevant pieces of that, of the string that have the same ID, because we're correlating these things with IDs, but they don't have any direct pointers to each other, which is great for quick iteration. It makes it easier on me to not have to manage interconnected state. But then I want to layer on top of that an accelerating data structure at some point, probably. So that'd be an upgrade to the fancy system to consider. Now, the next thing it does is once it finds a piece of the string that matches the alive it's trying to process, it's trying to figure out if this particular alive is being hovered by the mouse. So it's grabbing the screen rectangle, which is computed by taking the final layout position chosen by the game display logic from earlier, and using that to offset the rectangle from the layout. The layout, of course, positions all the strings, but it positions them relative to 0, 0. So the top left corner of the layout isn't set yet, and you set that like after the fact, once you have things like its width and its height and other things. So here we figure out which parts of the string or which alives are being hovered. And ideally it's just one. There's nothing preventing two alives from overlapping each other, except that the layout engine isn't supposed to generate those. But here we just, we look for we look for a rectangle that is intersecting the mouse position and mark the alive as mouse hovered. Then what we do is we look a little bit farther down and we see if this particular alive that we're processing right now is mouse hovered and the mouse is down, then we process its payload, right? And that's where we jump back into game logic. So if I show you I don't need to go into all the detail here because this is very specific to the game jam, but I'll just, flash through this maybe real quick. There's this giant switch with lots of different payload implementations. Each payload kind I made got implemented. So let's look at what a couple of these things are, because they might give us ideas about what needs to be happening in a payload. So the lowest level idea was this raw set state. There's some things that directly set fields in the game, like purpose and region and location and interaction and active item. There's something for changing the fragment pointer, the current fragment pointer directly. So you can say like, oh, when you click this button, modify the current fragment pointer directly. There are things like game commands, which are more complicated functions that I didn't want to make a separate payload for each one, but they didn't need any parameters. And that's a part of what makes them most interesting is payloads are more interesting when they involve parameters, and that's why there are so many of them. If they were all parameterless, there wouldn't need to be a payload kind at all, because you would just stuff a parameterless function pointer into the payload. But since the payloads sometimes have parameters, it becomes an issue of like, okay, we want to activate an item. How are we going to tell it which item to activate? Well, before that, we'll pass another payload that sets the active item, and then we can run an action that that will reference the active item. There's this thing called a game action. Why is this different from a game command? I'm not entirely sure, except that things got changed up here. Game actions, unlike game commands, do kind of have certain properties that are like a game command might do something like run the world generator, whereas a game action is like literally an action the player takes, so like using a key, forcing the lock open, drinking a potion, attacking with an item. Things like this are game actions. And so there's a sort of conceptual distinction. I'm not entirely sure that they need to be programmatically distinct, but they are. So there you go. You see what we got. We got a lot of different ideas there. I'm still not entirely sure what should be different here, but definitely this needs to be different somehow, because I want some of this to be game engine logic. Like I want the process of handling the alives and interacting with them to be game engine layer stuff, in the sense that if I make multiple games that have the same structure, I should be able to more or less just construct the fancy strings with the alives attached and hand them off to a handler that just is part of the game engine that does the work there. And it shouldn't be the case that I need to go and change the handler to have a different switch in the middle of the payload for each one. Maybe the answer is just always do a function pointer and come up with some plan for the parameters there. I'm not sure, but part of what makes this tricky is that since the payloads do need to be game specific and they do need parameters, it starts to become an issue of we need a way to pass parameters generically. It's like we want to be able to script out function calls that can depend on different game type, like different pieces of the game logic. Yeah, so I'm not quite sure. An idea is not popping in my head immediately looking at that, but I do need a better story there than what I came up with here. Something that doesn't require this much game logic showing up right in the middle of what is otherwise an engine layer loop. All right, to review so far, because we've kind of been at this for a little while, here's what happens inside the tick function, all the way from the top to the payload switch that we just looked at. First things first, we get started by constructing one or two fancy strings according to some game logic, running them through the fancy string layout, and then positioning them according to some more game logic. We then handle mouse interactions by scanning through the fancy string again and finding out which of the fancy alive things are being activated. If any of them are activated, we then run the payload attached to it. So that's what we've got so far. The next piece after that runs animations. So the alive text animates in a couple of different ways. If you are not hovering it, it just sort of sits there sitting still, but it has a brightness. And if you begin to hover it, the brightness comes up and it also bobs vertically. And as I said, I want that to not be considered game logic. So this animate stuff is all game engine stuff. If I made two different games with this engine without, doing anything to modify the aesthetics at all, you'd expect that you'd get the exact same look on alive pieces of text. Now, if I add more features and stuff, that can change, but this is not a part of each game doesn't define this on its own quite as much. The other thing that happens here is when you stop hovering it, the brightness fades back down. So there is a little bit of animation when you're not hovering it, if you just were hovering it, because it's got to fade the brightness back to its base level. And it also sort of like slides, it softly moves, it softly moves back to its resting position. It doesn't just snap there. So those are the pieces of animation that happen right inside the alives. And then what happens is, again, it loops through the entire string, finding all of the pieces of the string that are attached with, that are sort of associated to that particular alive state, and updates the rectangles for the layout positions in small ways. So this is, again, just mostly saying, hey, here's a good spot where better performance work might end up being useful. It's certainly pretty obvious what you could do better, which is, instead of going through all of the string, build that data structure up ahead of time that lets you more like accelerate going from a specific alive ID to the set of relevant strings. Another thing that I might want to do here is think a little bit more carefully about if I really want to modify the rectangle, or if there's other ways that I want to pass the animation state down and render it. But I don't need to be too fiddly here. Like, if this is under the layer of the engine, then tricks that I pull are also under my control a little bit. So yeah, if you're looking at this and you notice there are a few funny quirks to it, one thing it does is it sort of like loops through all of the strings and modifies their Y position, and then loops through their children and modifies their Y position. But you might think like, well, if this is a tree of strings, why isn't it recursive? And the answer is because we haven't looked at this yet, but the fancy string structure just isn't actually generic tree. It's a tree, but like the root, it has a special meaning. The children of the root form the main string, and if any of those main string pieces are set to be no wrap, so if they're set so in such a way that the spaces between some of the words aren't allowed to wrap, then it uses one more layer of the tree, and that's it. So you only have 3 layers in the tree right now. We'll get more into that if we look into the fancy string structure in detail and how we want to upgrade it. But these are like quirks that are hidden below that layer of the game engine that are not too concerning to me, because they're more about just the display and animation, making things, you might call it juicy or something, I'm not sure, making it feel alive, interactive in a good way, I'm not sure. Not particularly architecturally interesting, just some quirks that have to be dealt with by the engine. All right, final things that happen. We then save the current alive list that's in the alive system out into the game state. This again feels like some stuff that if this was a little bit more mature, it could be separated out in such a way that like this would this would be game engine logic, not game. It would not be mixed in with this function that's partially game engine and partially game logic. This is pure game engine stuff. The fact that I have to manually set up an alive system and then shuttle the alive lists back and forth, rather than having all of that sort of, still there somewhere, but easily shuffled away from view when you're dealing with the game logic, is just a matter of this not being a particularly developed architecture yet. But one way or another, I have to save the current list into some slot that carries it over to the next frame, and right now that happens right here. And we already saw this before. This is where the layouts and positions that got calculated by the game display logic now go into the game state proper so that they can make their way to the draw function. And with that, we have actually finally finished the whole tick function. Now, the big piece we really identified is that there's this game display idea. The other thing that I think we've identified, but we don't have an answer for yet necessarily, is how to update game logic. And that's because while I did scan over the various pieces of the game actions and the game commands and all the payload type things, it's so disorganized, there's very little clarity there. But I think I have an idea of why, of what needs to change there. So I think one of the glaring flaws in the current architecture as it's written is this current fragment pointer that lives inside the game state structure. And not just the fact that it exists at all, but a couple of things. It probably shouldn't exist, but it also definitely isn't purely game logic. It's classified as game logic for a couple of reasons. It's something that I want to clear out with everything else. And the logic block is that block of stuff that I want to clear at the beginning of each run. But there's a lot about it that isn't really game logic. The current fragment is sort of like the global state of the game, right? If I'm, pointing it at a certain thing, then the game renders through that. So if you start thinking about what kind of games I'm making or talking about making with this engine, you sort of start getting into states where you're like, okay, from the game jam, I remember being in situations where I wanted to know, like, is the player in the combat state right now, or have they just finished it? Are they interacting with an entity like a locked chest, or are they looking at a set of downstairs that they want to potentially go down further into, or other special gates or objects that they might deal with? Are they looking at an item that they're going to pick up and put into their inventory? There's lots of different states that they can get into. Have they just entered a new area and need the description for that, and so on? And so the states, how do I want to describe this? What state you're in is a good question to be able to answer cleanly. But separately from that, the flow of states, it has a more complicated relationship with what am I trying to say? So say you've just finished combat and you want to print out the message to the effect that combat is done. That might still involve printing out a combat message, even though you're outside of the combat state. You might be saying something like, okay, here are the things that you were fighting some monster, let's say, and it did some stuff, you did some stuff, and the final total result is that you've defeated it. And we want to print out the story piece that describes that that's what happened, and give you options of what to do next that are not from the combat system, right? And we kind of want to do these at the same time. And so it starts to get a little bit annoying to have some of the global state of the game is tied in with what the current fragment is. So if I'm in combat, then the current fragment will be the combat the combat fragment, right? But if I'm at the end of combat, I still need to render some of the combat system on to generate the text for the beginning of the interface. But some of the interface might also come from other systems in the game. And having a global singular pointer to a singular fragment at first felt fine if you were going to think of like each state is completely discrete. It doesn't share very much with any of the other states in the game. But the more I started trying to build systematic story stuff, the more clunky that felt, because the more it was like, oh, this fragment is missing the piece of the template that has the flexibility to show either combat options or exploration options. Oh, this fragment here, I forgot to put the title on it. Oh, the title showed up twice because I put the title inside of the fragment that's actually a sub-fragment of another fragment, and so on and so on and so on. And so I think that it would, over time, it would converge more and more to a point where you only want there to be one current fragment at all times. You don't want to control the top level state with a function pointer, and you don't want to derive what to display by pointing this pointer around at different fragments. Instead, you want to systematically be building your fancy string. And you might still want this idea of fragments, because you might still want to piece together bits and pieces here and there as you're going, but you kind of want one single code path that runs for everything. It might be like, hey, here's a little thing that it says, like, what did we wrap up before? How do we show the conclusion of combat state? How do we, things like this might be all kind of mixed together in there. And it just feels like what you want to display isn't always derived from a single like variable of state, right? It's not like a single integer could handle this either. It's not that I need to switch to an enum for the global state. There's stuff that I need to be a little bit more systematic that is not just a single state at the root level, but might be like a chain of a couple of key ideas that need to show up. Might need to be a couple of different things that are used to draw verbs from, to give the player the things that they're able to do. And ideally, I'd get to the point where I can do a better job of mixing verbs and prose like I do in the intro of the game jam. Which kind of falls away as the game systems get more complicated, and I lose the ability to compose this fancy string in one place. So I think the current fragment has to go completely. It's certainly not game logic. If it's anything, it's game engine. But I think it's even better if we replace the idea of pointing the current fragment at something with just the idea that your game has to define a game display function. And yeah, you could have a function pointer to point at a fragment as the only thing you do. You just call that current fragment every frame, but that's actually a pretty brittle and annoying way to build the system. And you probably want to do something a little bit different. Now, the other piece of this that I think I need to figure out, and I'm going to think out loud about this. So that was a little bit of thinking out loud already. But this is going to be even more thinking out loud than that. This is going to be the hardest part, is what do I do about the payloads? Basically, the payloads are 100% game logic and 0% game engine, right? The closest they got to being game engine was the change fragment and set raw state, but those were only there because I didn't have enough of an idea of what my game logic was. And so I took the things that I was making that were more game engine as being directly those were the only knobs I had on day one to expose. So you can kind of see through all of the payloads the game systems becoming more high level. If we take a look at the game state, we can see something kind of interesting that I started to do. So I have 5 special entity pointers, and they're kind of, I think of these as like registers. So the story fragments, the things building the fancy strings, and therefore the things building the payloads, they have direct access to the game state, so they can inspect any amount of the game state, right? They are a piece of that game display logic. They take game state in, and they spit fancy strings out. So they have, in the new vision of these things, what their primary input is the game engines, or the game state, and that game state can include like special slots. And this is what I was doing before. Now, I don't know if this is the right thing to do, but this is what I was doing, and I want to talk a little bit about why this might be a good idea, and maybe along the way I'll find some reasons why this might be a bad idea. But the idea behind this is, if I'm going to have operations that are game specific, they would not be something that the game engine has built in. The game itself is bringing these operations to the table. And those operations are parameterized. Like, I want to be able to say use item, and I want use item to be a thing that I don't have to build a special use item verb for every single item type. I just want the game to be able to say, hey, I have a concept of items. And when someone goes to use an item, they're going to specify which item they're going to use, and then they're going to say that they want to use that item, right? They're going to do something like that. Or they might say, I'm going to do the use item action and point that action at a specific item. It's like the verb is use item, and the verb needs a direct object to receive the action. And so I need to point the verb at something somehow, right? Something along those lines. And so to achieve that, I'm doing something kind of like registers. So the registers form, in low-level programming, the registers they form an ABI. So when you write a new procedure or a new function, you call to it by just jumping to it. And in order to pass parameters before you jump to it, you arrange some registers, maybe you arrange some stack memory as well in a specific pattern. And then when you jump into the function, it reads off of those registers. And since you, the caller, and you, the callee, had agreed on the protocol for what information goes in which spots, you manage to pass parameters. But there's no actual passing of parameters in a certain sense. There's just, you arrange the state of things before the call. The call is a jump into the handler for that, the logic that runs the procedure, and the procedure then looks in those slots to grab its parameters. And the same thing is happening here. So the idea is that the game logic itself contains some slots. And when you go to create a payload, what you can do is you say, hey, I want to create a payload that will set slot, the interaction entity. So I have a payload for setting the interaction entity. And then I have some payloads that might actually do something with the interaction entity. And so that kind of works. And so I'm wondering if maybe the answer here is that the engine provides... So I think what the engine needs to provide in a payload is a generic version of that. So what is a generic version of that? Well, the game logic is probably going to want to set like entity pointers, maybe some numerical parameters. If it becomes stuff more complicated than that, like strings and stuff, they can always, if you have a bigger blob of data like an array or a string that you want to pass, you might have to do something like first interact with the engine or with the game logic to create a stable ID system that lets you say like create stable IDs that are 64 bits for strings, and then say here's a new string that I need an ID for. It comes back and gives you an ID for that string, and then you pass that ID through. But the idea becomes the engine provides you say 16 slots, and each of those slots is a 64-bit slot for a parameter. And so when you create a payload, what you can do is you say, here's the action function that I want to run, and here is the parameter block. And that parameter block is just how to assign 64-bit values to the slots. Then if you want to say use an item, well, an item should maybe just have a pointer that is associated with it or something like that. Like you have, if it's an entity system, maybe there's a pointer or an entity ID system that provides stable IDs or something along those lines. And you take one of those handles, whatever they are, and you stuff it into one of the parameter slots. And so if you put it in parameter slot 0, you're saying, hey, this operation will understand what parameter slot 0 means. Now that might not be the most user-friendly thing ever, right? So that's one idea. Another way to structure it could be to give the slots names. So instead of passing a parameter by saying slot 0, here's some handle or pointer, you might start saying something like, okay, slot string item, right? So the key for the slot is the string item, and the value for the slot is then the handle to the item entity or something. And then the user operation has to have a thing. Either way, it has to have a thing that grabs its parameters. So in the first case, it's saying things like grab parameter 0 to constitute my entity for the item, or it might be saying grab parameter string item, right? Using the item string. I could also see like you could have free integer slot names. So it's not that it's a string slot name, it's still an integer slot name, but it's not a fixed 0 to 15. You got to just sort of hard hard brain computer person say like 0 is going to be the entity and 1's going to be this and 2 is going to be this. Instead, you have like a big enum. And so your enum can be like, okay, this is the item I want to use, and the amount of mana, right, can be 2 different things out of that. Like you got one of them's like game parameter underscore item. The next one's game parameter underscore mana amount. And then you put your parameters as the values associated to those keys so that you have something recognizable as like a binding point that carries a little bit more meaning. So I'm not entirely sure which of those is best. I think my intuition is that all of the ones that provide user aid are cool, but baking them like that at the lowest level might be a mistake, because it's possible that in the long run, I can still create an interface with prettier bindings, and that a sort of a conversion pass runs over this, sort of like what a compiler does that takes that high level stuff with the nice binding names and compiles it down, sort of doing a register allocation type of thing, or literally compiling it maybe, I don't know. But it feels to me like maybe I just go with the lowest level option that sort of gets this idea going. So I think that might look something like this. Okay, so in that diagram, what I am trying to depict is that each of these alives will contain as one of its properties the payload list, and a payload will be literally just a game action and the set of parameters, or the list of parameters to pass to that game action. And from the engine's perspective, because the reason the engine is relevant, by the way, is the engine has to actually process the payloads. So it has to provide the interface that you use to construct payloads, because it's defining their structure. It's defining all of that, right? If the payloads are defined outside of the game engine can't actually do the processing on them. So the plan then is that these payloads are carrying a thing called a game action, which from the game engine's perspective is basically uninspectable. There's nothing it can learn about what a game action is or what it means, but it has defined that a game action is just a thing that it knows how to call. And all it passes to the game engine is that block of parameters. And that block of parameters, from its perspective, is just some unintelligible block of handles. But it is up to the side constructing the fancy string to arrange those in a sensible way so that the game action, which is also defined by the game elsewhere, matches up, right? So the game action is sort of defined like a function, and the payload parameter block is like a function call, and it's not type checked because we don't have any way to link those up properly at this layer of abstraction. So as we're coding at this layer, there's neither type checking nor any user help in making sure to keep them in order or anything like that. But we're hoping that at some point, either we'll decide that this is too painful because shifting the parameters around isn't working out for us, or that we're going to shift up a layer, work at a higher level, and construct these things from that higher level in a systematic way, and that systematic thing that does the construction will do all the work of arranging it. Same way that we don't actually worry about getting ABI stuff wrong because our compilers just handle it for us now. So that's the architecture I'm going to shoot for in the next iteration of the game engine. So I think this has been a pretty good session. I've gone over the core structure of the game engine so far. I want to spend a little bit more time talking about some stuff that's a little bit more related to the game that I made itself. I'm going to do that in a separate, I'm going to cut here and go into that stuff in another log with the same style.